Questions 1 through 10 on the 2020 Grade 12 AMC 12A. Carlos took 70% of a whole pie. Maria took 1/3 of the remainder. What portion of the original pie was left? So Carlos has 70% and Maria took 1/3 of the remainder. Well, first of all, what is the remainder? It's 30%. So Maria takes 1/3 of that, which is 10. So what's left is 20. And that is the answer. So number 1, that would be C. The acronym AMC, American Mathematics Competition, is shown in the rectangular grid below with the grid line spaced 1 unit apart. In units, what is the sum of the lengths of the line segments that form the acronym AMC? All right, be careful here. Don't just count them up and think they're all 1, because they're not all 1. Okay, well, let's just count the ones that are 1. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so 13. And then I've got these ones. 1, 2, 3, 4. So 4 of those, but those are not equal to 1. Those have a certain value. And what is that value? Well, we can easily figure that out using Pythagoras. This is 1, and this is x, let's say. So 1 squared plus 1 squared is x squared, and therefore 2 is x squared, so x is root 2. So that is root 2. And there you go, 13 plus 4 root 2 is the answer, number 2, that is C. A driver travels for 2 hours at 60 miles per hour, during which her car gets 30 miles per gallon of gasoline. She is paid 50 cents per mile, and her only expense is gasoline at $2 per gallon. What is her net rate of pay in dollars per hour after this expense? So I have 2 times 60, 2 hours, and then 60 miles per hour. So that's 120 miles. The distance. And then it's 30 miles per gallon. So that means it's got to have 4 gallons being used. All right. So how much is this person paid? She is paid 50 cents per mile. So 0.5 times 120, which is $60. And then how much is the expense? Well, the expense is $2 per gallon. So there's 4 gallons. So the expense is $8. So 60 minus 8, which is 52, is her net income, I guess. But that is for 2 hours. And they want the net income per hour. So we just have to take that 52 and divide by 2. And when you do, you get 26 for dollars per hour. So number 3, that would be E. How many 4-digit positive integers have only even digits and are divisible by 5? We have a 4-digit positive integer. Now, if it is divisible by 5, the last digit must be either 0 or 5. That's the only way any number can be divisible by 5. But they're saying that this number can have only even digits. Well, therefore, it can't have the 5. So it can only have a 0. So that means that last digit must be a 0 according to the terms of the question. Now, what about the other digits? This guy here can be either 0, 2, 4, 6, or 8 because only even digits are allowed. This number also 0, 2, 4, 6, 8. And in this number, well, be careful here. 0, 2, 4, 6, 8 are my choices, but cannot be a 0. Why? Because if the first digit is a 0, then it's no longer a 4-digit number. It would be a 3-digit number, basically. So it looks like I have 4 choices for that number, 5 choices for that number, 5 choices for the third number, and 1 choice that's fixed as 0 for the last digit. And I have to multiply them all to get the number of combinations. And that looks like 4 times 25, which is 100. Number 4, the answer is B. The 25 integers from -10 to 14 inclusive can be arranged to form a 5 by 5 square in which the sum of the numbers in each row, the sum of the numbers in each column, and the sum of numbers along each of the main diagonals are the same. What is the value of this common sum? Well, if we make the square all the numbers, I want to figure out the sum of all the numbers. So that's going to be negative 10 plus negative 9 plus negative 8, dot, 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 all the way until you get to the positives, plus 8, plus 9, plus 10, and then we're going up to 14, right? So plus 11, plus 12, plus 13, plus 14. Now, these numbers all cancel each other, so the only really we have to figure out is the last 4, and that sum is 50. So the sum of all the numbers is 50. Now, there's 5 rows, right? It's a 5 by 5 square. And they're saying that each of those rows has an equal sum. All of the sums are the same. So if 50 is the sum of all the numbers, which would be the sum of all the rows, and there's 5 rows of equal sum, let's say that has a sum of x, 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 that means 5x is equal to 50. And therefore x is equal to 50 divided by 5, which is 10. So that is the value of that common sum. So number 5, the answer is C. In the plane figure below, 3 of the unit squares have been shaded. What is the least number of additional unit squares that must be shaded so that the resulting figure has 2 lines of symmetry? Well, one thing I notice is that this is not a perfect square. It's a 1, 2, 3, 4, 5 by 4. So the diagonals will not give symmetry. So if it was like 4 by 4, 5 by 5, then diagonals would give symmetry, but that's not the case here. So I think the only lines of symmetry would be one that goes straight across like that, and one that goes down the middle. So like this. Yeah, that's it. So then based on those 2 lines, I've got to figure out which ones to shade. Okay, so let's do this systematically. This one is shaded, so in order for this line to reflect as a mirror, this one has to be shaded as well. The corner here is shaded, so in order for this line to reflect as a mirror, this has to be shaded as well. And then let's see here, this is shaded, so this has to be shaded if this is the mirror. Similarly, if this is the mirror, then this has to be shaded, and so does this. And then let's see here, if this is the mirror, then the corners have to be shaded on the other side. So a lot of shading. So how many did I shade? 1, 2, 3, 4, 5, 6, 7. And 7 is one of the answer choices, and that is the correct one. So number 6 is D. 7 cubes whose volumes are 1, 8, 27, 64, 125, 216, and 343 cubic units are stacked vertically to form a tower in which the volumes of the cubes decrease from bottom to top. Except for the bottom cube, the bottom face of each cube lies completely on top of the cube below it. What is the total surface area of the tower, including the bottom in square units? Well, we have a situation, I'll draw a bird's eye view, where we have one sitting on top of the other, like something like that, right? So what happens is one bottom surface area is not counted for the top cube, and then that also covers that much area on the top of the cube below it. So I hope that made sense. So we have volume, and that is going to be S cubed, and then we have surface area of each side, and then we have the side length. And we are told those volumes are 1, 8, 27, 64, 125, 216, and 343. So we can easily figure out this table. This is 1, 1. This is 2, 4, 3, 9, 4, 16, 5, 25, 6, 36, 7, and 49. So to figure out the surface area, it's going to be, surface area of any cube is 6 times S squared. So the surface area of all these combined would be, I'll just factor out the 6 and just add up the S squareds. So 1 plus 4 plus 9 plus 16 plus 25 plus 36 plus 49. So if they were separate, then this would be the surface area. But they're not separate. They're stacked on top of each other like this. So we have to subtract. We have to subtract 2 surface areas for each stack, I guess. So for the top one, that would be 1, because we have to get rid of that from the bottom of the top cube because it's hidden, and from the top surface of the cube underneath. So that's why we multiply by 2. And then similarly, we'd have to do the same thing for 4, for 9, 16, 25, and 36. But not for 49. Why? Because 49 is the very bottom. And we don't need to subtract that because it says including the bottom. All right, so you do this math here. And when you do, you get 6 times 140 minus 2 times 91. And that is 840 minus 182, and that is 658. Number 7, answer is B. When the median of the following list, what is the median of the following list of 4040 numbers? All right, so it looks like we have consecutive numbers until 2020, and then we have consecutive squares until 2020 squared. So I guess before I jump into this, let me just talk a little bit about median, and I'm sure you already know this. Let's just say there's 4 numbers, and I said, what's the median? You would have to take the average of the middle 2. If it was an odd number, then it would just be 1 number. But this is an even number, so I will have to take the average of those middle 2. What are those middle 2? Well, the middle 2, if there's 4040, will be the 20/20th number and the 20/21st number. Those 2 numbers, whatever they are, I have to take the average of those. So add them and divide by 2. Okay, so let's figure out what it will be. This list obviously is 1 and then 1 squared, then 2, then 3, then 4, and then 2 squared, and then 5, and then 6, and then 7, and then 8, and then 9, and then 3 squared, and then so on, right? I just made sure that I put those in sort of chronological order. And then this just keeps on going. And then eventually it ends at 2020 for this list. And then that's it for that list. And then at that point onwards, we only have items from that list. Now I want to figure out what is the first item in that list that appears after 2020. Well, it's the first perfect square that's greater than 2020, and that is 45 squared. And just in case you want to know, that's 2025. 44 squared would be back here somewhere, because 44 squared is 1936. Yeah, 1936. Okay, great. So I want to ask you, what number is that in terms of its place? It's not the 20/20th number, because remember, we have stuck in a bunch of these perfect squares. All right, we stuck in how many? 44 of them. So 2020 plus 44. So this is the 2064th number in the list, right? 2020, these 2020, and then the 44 perfect squares that I had to place in chronological order. Okay, now that's great, but I don't want the 2064th number. I want the 2020th number. And then eventually I'll get the 2021st number. Or 20 for 21st would be ST, right? Well, it doesn't really matter. Okay, so how do I get the 20/20th number? Well, I have to go back from this 44 numbers. So 2020 minus 44 is how far back I have to go. And 2020 minus 44 is 1976. This number is the 20/20th number. Almost my year of birth, not quite. I was born in 1974, but it's completely irrelevant. Okay, so therefore the 2021st number would be 1977. So there we go. That is what we wanted. 1976 and 1977. And then to get the median, I've got to take the average of those 2 guys. So add them and divide by 2. Oops. 1977 divided by 2. And when you do, you get 1976.5. Therefore, number 8, that would be C. How many solutions does the equation tan 2x equals cos of x over 2 have on the interval 0 to 2 pi? Well, you're practicing, so practice drawing a graph. Get out a piece of paper and draw this, and then draw this. You just put like a few points and then connect the dots and do it over the interval 0 to 2 pi, which is what? Pi is 180, so 0 to 360. And I did that on a very cool website called desmos.com, and this is what I got. So these lines right here, the red ones, represent the tan part of the graph, and this purple line represents the cos part of the graph. And it's from the interval 0 to 2 pi. Pi is in radians, right? 3.14, so 2 pi would be 6.28. So we only have to be concerned with this graph till about 6.28, which is approximately here, I think, until there. So how many times do these graphs cross? We have 1, 2, 3, 4, and 5. 5 points of intersection. So number 9, the answer is E. There is a unique positive integer n such that the log to the base 2 of log of n to the base 16 is equal to the log to the base 4 of log of n to the base 4. What is the sum of the digits of n? Many ways of doing this question, really, and the recommended way, of course, is the fastest way. And I can do it the long way or the short way. Obviously, on a math contest, you want the short way. So I think this would be a relatively decent way of doing it, is that this part here, I'll just call x. So that's log of 2, log of n, and that whole thing, however you want to call it, is x. So based on simple log rules, that would mean that 2 to the power of x is equal to log of n to the base 16. And then once again, using simple log rules, 16 to the power of 2 to the power of x would be n. And then we'll manipulate this a little bit. 16 is what? 4 squared. So it's going to be 4 to the power of 2 to the power of 2 to the x. And that's going to be 4 to the power of 2 times 2 to the power of x. And I think I'll leave it at that for now. Now we do the exact same thing, but on that guy. So it's the log of base 4 log of n to the base 4. And that I am setting equal to x. Okay, using simple log rules, 4 to the x is equal to log of n to the base 4. Again, using simple log rules, 4 to the power of x is equal to n. Again, as before, we want to manipulate this a little bit. 4 is 2 to the power of 2. Yeah. And I think we're ready to make a comparison here, because we've got n in terms of 4 to the power of something there, and we have n in terms of 4 to the power of something there. So that means that 4 to the power of 4 to the power of x is equal to 4 to the power of 2 times 2 to the power of x. Bases are the same, so the exponents must be the same. So 4 to the power of x is equal to 2 times 2 to the power of x. This is going to be 2 to the power of 2 to the power of x, and this can be combined as 2 to the power of x plus 1. So the left side becomes 2 to the power of 2x, and this becomes 2 to the power of x plus 1. So again, bases are the same, exponents must be the same, so 2x equals x plus 1, and therefore x is equal to 1. X equals 1, so now we can easily figure out what is n by plugging it back into there. And when we do, we get n is equal to 4 to the power of 4 to the 1. And that means that's just 4 to the power of 4, which is 256. And they want the sum of the digits of n, so that's going to be 2 plus 5 plus 6, and that is 13. So number 10, the answer is E.